Draw the typical input and output characteristics of an NPN transistor in CE configuration. Show how these characteristics can be used to determine the input resistance Ri and current amplification factor beta. So let me see the characteristics of an NPN transistor. There is the input and output. In input and output, we have input and output. In input, we have input current. Input current, we call that is IB, and input voltage, that is VBE, and the output voltage here, output voltage VCE. Similarly, in the output, we have output current IC, output voltage VCE, and input current that is IB. Okay. The first one is the input resistance. If you are going to see the graph, here it is in the y-axis we have the input current. It is very small, that is in terms of microammeter. And in the x-axis we have input voltage, that is in terms of very small values, 0.2, 0.4, 0.6, 0.8, 1.0. And here 0.6 we can see the output voltage at 10 volts. And the Ri, the resistance, input resistance is given by Ri is equal to input resistance, that is the change in the input voltage, that is delta VBE divided by input current, delta IB into output voltage, that is VCE. And the current amplification factor is the ratio of the current connector in the y-axis and the connector emitter voltage, it is in the x-axis. Here suddenly rise in the beginning, and after the voltage will be there, then the constant values we can observe here. And this is the beta, that is the amplification factor beta. Beta is equal to delta IC divided by delta IB into VCE.